Yippee, check out the green background and the smiley face. Why is that? This is the last chapter of Unit 3 and the last chapter of your Foundation GCSE about to get demolished. This is Pythagoras. I love this stuff. It's such good fun. And I seem to remember loads of you were brilliant at it back in Key Stage 3. All of you were great at this. So listen, I'm going to teach it the way I always used to teach it. Page 265, I've got a little triangle like that, question 1A. Again, nice and crude. Question 1A, I've got right angle. Remember, Pythagoras only works with right angles. This is 5 centimeters across here, and this is 12 centimeters across here. Remember, these two smaller sides, when they're squared and added, makes the long side squared. So essentially, the two baby squares make the mummy square. That's how I used to teach it, remember? So I've got to work out the length of the hypotenuse. That's a flash Greek word meaning the longer side. So that's the spelling, hypotenuse. I don't know why it's called that, but that is the mathematical word for the longest side of a right angle triangle. So I'm going to work out this hypotenuse. Let's just call it x. So here I go. Remember, the mummy square is that baby square plus that baby square. So what do we got? We've got 25 plus 144, 12 squared, altogether 169. I happen to know that if you press the square root button on 169, you find that the mummy hypotenuse x is exactly 13 centimeters. Right, bit quick, but I know you're good at this. I think I'll do another one. This is 1D. It looks like that. It looks terrible. Never mind, it's got right angle there. We're 24 millimeters down and we're 7 millimeters across. Now look, if we've got a right angle there, opposite the right angle is the big side, the hypotenuse again. So we know we've got to add the squares of got to add the squares of 7 and 24. So let's just call it x again. So x squared equals the baby square plus the other baby square. 7 7s are 49. 24 squared, around about 600. So 24 times 24, bam, there you go, 576. Add them both up. So 625, 625, and I know that x is going to be the square root of 625, and I know just from experience that root 625 happens to be 25, because 25 times 25 is 625. Okay, my dears, that's that one, and question 1 is done. I'll just turn over. I think I'll do question 2A. I'm given a rectangle. Ooh, we're supposed to be scared now, are we? That's a rectangle, and I've got a dotted line, which is the diagonal, and they've called that x, would you believe? And I'm given 3.8 centimeters height, and I've got a 15.2 centimeter width or length. Don't know what you call it. Find the length of the diagonal in each of these rectangles. I'm just going to do one of them because it's boring, isn't it? Right, I've got a baby and a baby. You've got to find the mummy. Same routine. Mummy square equals baby square plus the other baby square. Why do I refer to them as babies? Because when I work out the mummy, she's going to be longer because she's a mummy. Now 3.8 square, here we go. 3.8 squared is 14.44. Now 15.2 squared is 231.04. Add them both up. That gives me 245.48. Now press the square root button on that. Again, we're showing our working. This is lovely, easy grade C stuff. So x is going to be whatever the root of that is. Bam, equals. I've got 15.667. I'm going to one decimal place actually, just to, because I can go to 1 dp because the question. So 15.7 centimeters, and she is a mummy. She's bigger than the 15.2, and so I'm happy we got it completely right. Now, for question 3, we're given something like this. This is question 3A. Triangle, hypotenuse, other short side, right angle, and we're given the mummy of 15 centimeters. And we're given the baby of 12 centimeters. We've now got to find the other baby. Now, nobody would add a mummy square to a baby square to get a baby square. No, no, no. What you do, you say the baby square is going to be the mummy squared, take away the other baby square. That's good enough. So the mummy square is going to be, I think it's 225, take away 144. What's that going to be? 56. Let's grab a calculator because I ruined it. 225, take away 144, bam, 81. Oh lovely. You know, don't you? If you take the square root of 81, you're going to get 9. So therefore the other baby side is 9. Alright? Lovely. Let me show you why that's the case. So let me just take this. Our red and green don't look so good, does it? Let me just take this and just work over here. Look. Essentially, I've got x squared plus 12 squared equals the 15 squared. Okay, that's the correct way around we should do it. The two little ones make the big one. So to get one of the little ones on their own, you take it next door, like that, and subtract. Just like you were solving an equation. And in fact, it's exactly what you're doing. You are solving the equation, aren't you? You're substituting what you know and finding the missing bit. Alright, that's that, etc. So etc. means what I just did over here. Alright, turn over the page and go back to black. Right, anything else worth doing here? Not really. Let's do one from question 5. Question 5 is, I think I'll do 5D. I rather like it. This may cause some of you to cry just a little bit. So I'll do that. I'm being given a right angle there. I'm told that's the same as that. So guess what? It's isosceles. I'm told that's 8 centimeters, and I've got to find mystery x. Look, isosceles triangle. If that's 8, then so is that 8. Okay? So no worries there. Now let's find the mummy. So mummy square equals baby square plus the other baby square. That's 64 and 64, yeah? 8, 8, 64, 128 altogether. So let's get mum on her own. You press the square root button of 128, and here we go. So 128 rooted is syntax error. Press square root first. Square root of 128 is not 13. It's 11.31. So 11.3 to 1 decimal place is justified. All right. That is the length of the biggest side. That will do. What's on the other page? Anything good? Yeah, I'm going to say that for another video, I think, just to break it up a little bit. About how long we've been going on for. I'll be looking at questions 7, 9, 10 in the next video. They're slightly more complicated ones, and I'll take it more slowly. In the meantime, enjoy the last unit of your career.